Hi everyone, welcome to my channel Icon Teacher. I am Saraj Prasad. With a view to help the students online, I started this channel. In this session, we are going to discuss the first chapter of class 11 mathematics, that is sets. In this module, you are going to learn what is a set, the number theory, the different ways of representation of sets, and the types of sets. Okay. To begin with, let us see what is a set. A set is a well-defined collection of distinct objects. So let us see the two keywords you could see, that is well-defined and distinct. So here you could see that there are two keywords. One is well-defined, the other is distinct. So here you could see a collection is said to be well defined if it is possible to say clearly that a particular object belongs to it or it does not belong to it. And the keyword distinct means that the members of this set are different from each other. So once again, a set is a well defined collection of distinct objects. So let us see the few examples of set. Well, the first example, collection of natural numbers less than 10. So what are the natural numbers less than 10? They are 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this can be an example of a set. Then the second example, collection of vowels in English alphabet. So they are A, E, I, O and U. So these are few examples of collections which are also sets because they are well defined and distinct. They have distinct objects. Now let us see what is not a set but it is simply a collection. Very simple way to remember is that if the opinion varies from person to person, then it will not be a set but it is simply a collection. So you could identify that with some keywords like beauty. So whenever you find the word beauty, that means it's simply a collection because the beauty lies in the eyes of the beholder. So the opinion varies from person to person. So when we talk about collection of beautiful flowers, so one may say rose and lily, the other person may say lily and jasmine. So we could say that the opinion varies from person to person. In such case, it is simply a collection but not a set. So the other example could be the collection of bright students in the class. So even that person, it varies from person to person. So that could be also another example of simply a collection, but it need not be a set. So it is not a set, but it's simply a collection, right? So coming to the next example, collection of students in a class whose marks is above 80% is once again a set because clearly we could identify the students who scored above 80%. So that will be a set. So I hope all of you understood what is a set and what is simply a collection. So one should understand that all collections are not sets, but set is a collection. Now let us see what are elements of a set. The members belonging to a set are its elements. It is denoted by the Greek letter epsilon. The symbol epsilon the slash denotes does not belong to. Just like how you have equal to with a slash, which means does not equal to. So same way here also, epsilon with a slash means it does not belong to. So let us consider an example. A is a set of vowels in English alphabet. So we have A is equal to A, E, I, O, U. So we could observe that this member A is an element which belongs to set A. So here A, E, I, O, U, they are belonging to the set, so they are called as elements. So A is an element which belongs to set A. So the symbol for belongs to is epsilon symbol. So this is a symbol for belongs to, and we write capital letter A, which means which is the name of the set, that is set A. So A is a member of set A. Similarly, E is a member of set A. So E belongs to capital A. Similarly, I belongs to set A. O belongs to set A. And also U belongs to set A. So we can say that all these are the different members of the set. So each of the member belongs to set A. But apart from these five elements, if you are talking about any other element which is not in this collection, then you write it as does not belong to symbol. So let us see. For example, if I write H, H is not a member of this set. So how do I represent it? So I put an epsilon symbol with slash. H does not belong to set A. Similarly, B does not belong to set A. So this is how we are going to do the representation. I hope it's clear. So we use the epsilon symbol to show that it belongs to the set A, and if we use the symbol does not belong to with epsilon with a slash, which says that it does not belong to. Now let us discuss the different types of numbers. The first, natural numbers. Natural numbers. Natural numbers. So the natural numbers are represented by a symbol n. So n stands for natural numbers. The other name for natural numbers is counting numbers. So it is also called as counting numbers. Counting numbers. And then these numbers are written like 1, 2, 3, 4, so on. So if you observe this set, it has infinite number of elements. So we call this set as an infinite set. So it starts with 1. So 1, 2, 3, 4, so on. So natural number set is also called as a set which contains 1, 2, 3, 4, so on. And it is also called as counting numbers. Next, the second is whole numbers. Whole numbers, they are represented by W, and they start from 0, 0, 1, 2, 3, dot dot dot. So which means that they are again infinite in number. So once again, whole number set is also an infinite set. So whole numbers start from 0. Next is integers. So all the numbers 0, plus or minus 1, plus or minus 2, plus or minus 3, so on are called as integers. They don't have any decimal part, or decimal part is 0. So integers are 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on. Once again, this is an infinite set, and it is denoted by the symbol I, or it is also denoted by the symbol Z. So integers symbol is either I or Z. Then we have positive integers. Positive integers. So positive integers means they are all greater than 0. So from the integers which we have seen here, the positive integers means those integers which are greater than 0. So we could observe that the integers which are greater than 0 are 1, 2, 3, 4, so on. So these are the positive integers. Now there is a small difference between positive integers and non-negative integers. So let's write down what are non-negative integers. Non-negative integers. Non-negative integers means the integers are not negative. So those integers which are not negative means they also include 0. So they start from 0. So 0, 1, 2, 3, so on. So these are all non-negative integers. Similarly, we can have negative integers. Negative integers. So the negative integers means all the numbers are less than 0, which are integers. So they are -1, -2, -3, so on. So they are all negative integers. And again, if we say non-positive integers, non-positive integers. The non-positive integers are again including 0 because they don't include positive integers, they include 0. So 0, 1, 2, 3, sorry, -1, -2, -3, 0, -1, -2, -3, so on. So they are all non-positive integers. So non-positive integers include 0 and all the negative integers. So 0, -1, -2, -3, so on. So these are called non-positive integers. Then we have rational numbers. Rational numbers. They are represented by the symbol Q. So as we have seen that a rational number is a number which can be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. So a number which can be expressed in the form of P by Q, where P comma Q are integers and Q not equal to 0. This can be a rational number. Then the next comes irrational numbers. Irrational numbers. So we represent this with Q complement or Q prime, which is the complement of the set, which we will be learning in detail in the future concepts. So irrational numbers are nothing but the complement of the rational numbers. So it's called Q complement, and these numbers are those numbers which cannot be expressed in the form of P by Q, which cannot be expressed in the form of P by Q. Example, root 3, root 2, so on. So these are the different examples of irrational numbers. So I hope all of you understood the different numbers, the natural numbers, whole numbers, integers, positive integers, non-negative integers, non-positive integers. Then we have seen what are rational numbers and irrational numbers. Okay, so let's have a quick recap of these numbers once again. So the first one is natural numbers. In the natural numbers, they are also called as counting numbers, represented by a symbol n. Example 1, 2, 3, 4, so on up to infinity. So it's an infinite set. So it's written as 1, 2, 3, 4 dot 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 within the braces. Then the second category is whole numbers. It starts from 0. So 0, 1, 2, 3, so on, represented by W. Then we have the third number type is integers. So they are 0, plus or minus 1, plus or minus 2, so on. And they are represented with I or Z. Then we have positive integers, which are integers which are greater than 0. They are 1, 2, 3, 4, so on. And non-negative integers are those numbers which are positive as far as it can be 0. So it can be 0, 1, 2, 3, so on. And then we have seen what are negative integers, which are those integers less than 0. So -1, -2, so on. And then non-positive integers again include 0. So we have 0, -1, -2, -3, so on. And then we have rational numbers which are represented by Q, which is any number that can be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. And any number that cannot be expressed as P by Q is said to be an irrational number. It is simply a complement of rational numbers. So these are the different types of number systems. Then the last is the real number system. Real numbers. So real numbers are nothing but the union of the rational numbers and irrational numbers. So all the rational numbers and irrational numbers together are called as real numbers. real numbers. It is denoted by the symbol R. So real numbers are represented by the symbol R. I hope it's clear about the different types of numbers.